Assalamu alaikum wa rahmatullahi wa barakatuh. This is me again, Muhammad Hayyan Al-Sibai from the Faculty of Engineering Technology, University Malaysia Bahang. I'm continuing with you introducing microcontrolling start as professional. So in this course we already covered 6 modules. This module is a little bit theoretical because they cover actually the structure of the AVR, and I used a little bit some instruction in assembly because actually I want to introduce to assembly language, which is closer to the machine language. From now on we are going to use C programming language to program our microcontroller. As I explained before, C programming language is considered as high level language, which is more closer to human being. So from now on you are going to have some interesting applications because we will use C programming language to do this application, which is much more easier, as you will see in writing the program, and you will put a lot of load on the compiler. So the compiler will do the things for you, and it will change your C code to assembly or machine code to be uploaded to the microcontroller. So it's important to know the structure, but no need to do it in very long procedure to write your program, since you can use the C language, which is making things easier. The language that we are going to use with the AVR Studio called Embedded C. So Embedded C is actually not the standard ANSI C, but it's very close to it. So AVR company successfully managed to write the Embedded C compiler to accept code which is very close to C. Why C is one of the important languages to be used with microcontrolling? As you know, the language C supports the idea of having libraries and header files. So in AVR Studio there are a predefined library which is pretty big and very complex that offer portability in its header file. So you can use a lot of libraries to support your microcontroller. No need to write everything from the scratch. This is the power of using C language. But previously, when we studied assembly, we included a header file for each microcontroller. In using C, things are much more easier. There's only one header file that you can include for all your microcontrollers from the family AVR. This header file is avr/io.h. It's very similar to include IOStream. Okay, so in NCC or C++, you usually include IOStream. Instead of this, you will include avr/ioh, which has all the things that going to be used in input output, including of course the DDRB instead of the real address and so on. So it's resolved the problem of handling the registers and provides a convenient way to treat the registers as variables. So from now on, no need to also worry about the registers. So register 1, register 20, whatever, just use a variable. You can use many types of data, and you can write your program similarly as what you do in dealing with your PC when you write a program for your PC. So let's have a look on the structure of your program. So this is a typical embedded C program. It will include avr/ioh. Then, as usual, as any C programming code, it will have the main. Keep in your mind that microcontrollers are loops. Okay, what I mean by this, that microcontrolling is a loop of things. So you need to continuously read from a sensor and do operations. So that's why we always have this while one in most of our code. Okay, so we have main and then we have the while one. Our code goes here. If you are familiar with Arduino, this is replaced by a function called loop. Okay, we will see Arduino later. Data types, we say that microcontroller in the hardware is only support one data type, which is integer, signed or unsigned. It's 8-bit integer. But here in C, using the library, using the compiler, you can use all of these kinds. And don't worry, because the compiler will manage them and will allocate a suitable memory for them. So it will use more than one place in the memory to provide you the facility of having these data types. If you are not familiar with C, here is just a review. So I'm just not even going to read the slides. I'm just going to show the slides, and the slides is available for you in Open Learning. You can have a look of them just as a reference, a quick reference if you want to refer to. If you don't have a good knowledge in C, you need to have another course or book to read more about C language. Here I just review the arithmetic operators. So as you see, we have multiplication, division, modulus, addition, subtraction, increment, decrement, negation, and generally plus. For rational and logical operators, we have greater, greater or equal, smaller, smaller or equal, equal, not equal, and we have the logical operators not, and or. For bitwise operators, which is the difference between logical operators and bitwise operators is applied bit by bit. Logical operators is for the statements, the whole statement. If ANDed, the result will be true or false. Here bitwise is mathematical operators that will apply for bit by bit. We have the complement or not, we have bitwise and, bitwise or, bitwise exclusive or, and we have the shifting left and right. Let's now have an example of the bitwise operation. Let's suppose we have two variables x and y. So as you see, we use that suffix 0b. That means these values in binary. So this is applied here also because it's the same combiner. I mean the assembler and the compiler are from the same company, so we can still use these kinds of suffixes. So 0b 0011 and y equal to 0b 0110. So this is 3 and this is 6, as you know, in decimal. Now if we apply or, the bitwise or, as you see here, so a new variable z, if it's equal to x or y, the result will be binary 1 1 1. So the result is 7. Why is this? Because 0 or 1 1, 1 or 1 1, 1 or 0 1, 0 or 0 0. If we apply and z equal to x and y, so the result will be 0 0 1 0. Why? Because 0 and 1 0, 1 and 1 1, 1 and 0 0, and 0 and 0 0. Okay, the same apply for x or not. As you see, not x is 0 0 1 1, so the not of it will be 1 1 0 0. Okay, shifting, so adding 0 here, so the 1 1 will be shift to the left and we add 0 here. Shifting right, we add 0 from the left, so we have only 1. This one is thrown away and we have only 1 0 0 0. Bitwise operations are actually important for one technique which is very important. It's called bit masking. So the bit masking is used actually if you want to keep some bits without a change in one byte. So you have a byte, for example, let's say it's the register which is connected to port B. You want to change the pin PB2 only and keep the others as they are, so you mask it with OR. So I will show one example for setting and one example for resetting or clear. Let's say we have value x. With this value is 0 1 1 0 1 0 0 1. I want to set bit 2 and bit 4 of x. Set means to make them 1 and don't change other bits. So the solution for this is to do masking with this mask. So the mask is all 0 except bit 2 and bit 4, they will be 1. So after do the masking, if I mask this, so as you see 1 or 0 1, 0 or 0 0. So now this 0 is ORed with this one and it will be set to 1. The same apply here. So as you see, x is all the bits are the same except bit 2 and bit 4 are changed to 1. Now let's say I want to clear bit 3 and bit 5. So this is the new x. Now I want to clear bit 3 and bit 5. In this case I use AND. So masking with AND. So this is the new mask. Now as you see, bit 3 and bit 5 are 0, the others are 1. I do the AND operation and as you will see, this will keep as they are. So 1 0, this is the new x. I'm applying the mask on the new x and this is the mask. So all of them will remain as they are except bit 3 and bit 5. They will change to 0. So this is the benefit of masking. Continuing about the C language review, so we have what's called the assignment operators. The equal is the original assign, so x equal to y here. Then we have what's called the shortcut way of writing assignment. So plus equal means if we write like this, so x plus equal y, that means x equal to x plus y, and this is applied for many operations. The good about using C, that no need to worry about the branching and to know which bit is changed in the status register and so on. Just use it in the same way that you are familiar with if you are familiar with C programming. So for example, if temp is greater than this value 150, you can fan on, so you call a function also, you can call a function. So all what you learned in C is, let's say, most of them will be applied in embedded C, which is applied on the microcontroller. How is this happening? Through the registers, through the status register, through the ports. You don't need to worry about any more. So this is the if else, also nested if can be applied. Also the shortcut of if, so temperature 150, if greater, fan on, otherwise else, fan off. The loops also applied. We have while expression, for expression, and do while expression. All of them applied here. No need to worry about branching. No need to worry about the status registers. In microcontrollers, the hello world program, the first program you do is blinking an LED. So let's see this program very quickly. So we have to include AVR-IOH, which should be included in all programs to use the input-output streams or input-output boards. Then we have utility delay. We use this one because actually we are going to use this function. So this function is member of this library. Then the program is like this: to set board C as output. No need to load to a register and then from register to the board. Just directly you write DDRC equal to hexadecimal FF. Now in the loop, board C equal to FF, that means all the LED will be on. Delay, board C equal to 00, that means all the LEDs will be off. Delay again and go back. So this is continuous loop. Of course, if you want to compare these 4-line programs with what we are supposed to do in assembly, you see how much it's simpler. So in assembly, we need to load to a register, move from the register to DDB, then we have loop, and this is the jumping, so this is the loop, and then we load to a register, from register to board. We call a function delay similarly, but we need to write this function by ourselves, and this function, to make it long time, we need a lot of knobbing and looping, and it's according to the speed of the microcontroller, and we do delays. Actually, this is what we are supposed to do in the machine language. So the compiler task is to change this code to something similar in this, written in the machine code. So that's all about the introduction about C. It's just like telling you how you are going to use C programming. It's not about teaching C language, because you are supposed to be familiar with C language and all of these things. If you are not, you need to read a book or have another course regarding this one. Thank you for listening. Have a nice day and see you in the next video.